So we'll continue on with this series of exercises. We want to find critical numbers, find the intervals on which the function is increasing and decreasing. We want to find relative min and max, and we want to use our graphing calculator to verify. So we'll do 21 and 23. In this video, you really should do 22 and 24 and then verify your results with your graphing calculator. Alright, 21. We start off with f of x is equal to 2x cubed plus 3x squared minus 12x. We're looking for the first derivative. The first derivative is going to be 6x squared plus 6x minus 12. And it's best to first factor that. So we'll get 6 times x squared plus x minus 2. One more simplification. That factors to be x minus x plus 2, x minus 1. And you should always double check your factoring. That gives us x squared minus x plus 2x plus x minus 2. Good. Now we want to set that equal to 0. So that's our derivative. And we may want to highlight that because we're going to come back to use that. And I always like to use the derivative in factored form when I'm doing the first derivative test. It makes it so much easier. But now we need to solve that for 0. So we have 6 times x plus 2 times x minus 1 is equal to 0. We divide through by 6 and we get x is equal to negative 2 or x is equal to positive 1. Those are our two critical numbers. We're going to make our sign chart now, putting our two critical numbers 1 and negative 2. We choose test values. Negative 3, 0, and 2 should work fine. I remind myself that I'm working with the first derivative. And I'm going to plug in now into the factored form, and you'll see how easy that is. Plug in negative 3. The first term will be negative. Plug in negative 3. The second term will be negative. Negative times negative is positive. And so I have positive on this interval. Plug in 0. First factor, positive. Second factor, negative. Positive times negative is negative. Plug in 2. First factor, positive. Second factor, positive. Positive times positive is positive. And so we get something that looks like this. Increasing, decreasing, increasing. And we appear to have a relative max at negative 2 and a relative min at x equals 1. So we'll need to find the values that go with these. First of all, we note function is increasing from negative infinity to negative 2 and from 1 to positive infinity. It's decreasing from negative 2 to 1. Then we have a relative max at x equals negative 2. And recall that in order to find the y-coordinate, we have to plug back into the original function. So negative 2 to the third is negative 8. So let's see, we want f of negative 2, and that's going to give us negative 8 times 2 is negative 16. So negative 16. Then negative 2 squared is 4 times 3 is 12 plus 12. And then negative 2 times negative 12 is positive 24. And so that appears to happen at 20. The maximum is at -2 and +20. The relative minimum is at +1. So we plug into the original function, we get 2 plus 3 is 5, minus 12 is -7. So that appears to be at 1, -7. So we've found the critical numbers, -2 and +1. We've found the intervals on which the function is increasing, -infinity to -2 and 1 to infinity, where it's decreasing from -2 to 1, and we use the first derivative test where the derivative changes from positive to negative to identify a relative max at -2 and 20, and where it changes from negative to positive to identify a relative min, which occurs at 1 and -7. Now we should just plug this into the calculator to double check, and we have 2x to the third plus 3x squared minus 12x, and zoom standard, and let's see what we have here. We're going to need to adjust our window a little bit. We don't need so much y space, so maybe from -5 to +5, and from -10 to 20 by 2's, and let's see what we get here. Alright, so we want to verify. Then the basic shape looks good. We want to verify that our maximum occurs at -2 and -20. So we do second calc, a maximum, and left bound. Now you can type in numbers here too if that's -1, 2, 3, 4. So let's say -4 would be the left bound, and -1 would be a right bound, and guess, and we get -2 and 20. We were good there. Then move this over just a little bit, and we want to verify our minimum. Option number 3, we'll say the left bound is at 0 and the right bound at 1, 2, 3, and enter, and we get 1 and -7. So that was all good. I'll take a picture of this, and we're good to go. Okay, so let's go on then to problem number 23. Now with problem 23, we have f of x is equal to x minus 1 squared times x plus 3. Now we can find this derivative in one of two ways. We can multiply out the x minus 1 squared and then multiply that times x plus 3 and do the power rule on everything, or we can do the a product rule here. And my first instinct is that I think that multiplying out is going to be the quicker way to go. So x minus 1 squared, we should note that that is x squared minus 2x plus 1 times x plus 3, and now we multiply everything on the left times everything on the right, so it's x cubed plus 3x, then minus 2x squared minus 6. Sorry, that was x cubed plus 3x squared, then minus 2x squared, and minus 6x, then plus x, and plus 3. We're going to simplify that now. X cubed plus x minus 5x plus 3. So however you got to this point, we're ready to take the derivative now. The derivative will be much simpler now that we've done that. 3x squared plus, okay, hang on one second. So that should have been x squared above there. So 3x squared minus 2x squared should have left us with 1x squared. Now we take the derivative 3x squared plus 2x minus 5, and that is our derivative. So what will we have here? Let's see whether this factors. Hopefully it factors. Otherwise we're going to have to do a quadratic formula with this, which is not a lot of fun. And it turns out that it does indeed factor to be 3x plus 5 times x minus 1. Now, I hope you could have gotten to that point. I really don't have the time in this video to show you the magic way of going about getting that. That's our derivative. So we should circle that or highlight that. We're going to use the factored form. Next, we identify the critical numbers. Critical numbers are x equals 1 and x is equal to negative 5 over 3. Two critical numbers there. First task done. Second task is to make a number line, a sign chart, putting our negative 5 over 3 and positive 1 down. Choose some values. Negative 5 over 3 is negative 1 2/3, so negative 2, 0, 2 should work fine. We recall that we're working with the first derivative, and we're going to plug those values into the factored form. Plugging in negative 2, I get negative, negative, which turns out to be positive. Plugging in 0, I get positive, negative, which is negative. Plugging in 2, I get positive, positive, and positive. So increasing, decreasing, increasing. That tells me that the function is increasing on negative infinity to negative 5/3 and from 1 to infinity. It's decreasing from negative 5/3 to 1. Alright, we have a relative max at 5/3 and we have a relative min at x equals 1. The relative min is going to be much easier to tell. That is at 1 and 0. Plugging into the original function, we get 1 and 0. Now, if you wanted to use your graphing calculator at this point to test to get the actual coordinates, I have no problem with that. Let's bring that up. So we put in our function x minus 1 quantity squared times x plus 3, and we zoom standard and get something like this. We can see that our maximum is at 4. Left bound, negative 5 and 0. Enter, and we get negative 1 2/3, so it's 9.414, whatever that is. And we'll just verify real quick that the minimum is at, the left bound could be 0 and 3, and that happens to be at 1, 0. So that one was accurate there. So I'll take a picture of this and leave it on our workspace, and we'll go on to the next problem. And that'll do it for these two problems here.